Ask an AI agent something from this morning's news or a private document it's never seen, and it can answer correctly, even though its training ended months ago and it never memorized your files. It's not remembering. It's not psychic. It just quietly went and looked something up first, in the split second before it answered you. Here's the trick behind almost every AI agent that sounds like it knows things it was never trained on. Every large language model has a training cutoff, a hard date after which it has seen nothing. Ask about something newer, or about your company's internal wiki, or your own private notes, and by default it has no idea. Worse, when a model doesn't know something, it doesn't reliably say so. It guesses, fluently and confidently. In 2023, one AI demo gave a single wrong factual answer live on stage, and the company behind it lost roughly $100 billion in stock value within a day. That's the cost of confident wrongness at scale. The obvious fix, just retrain the model on the new information, is slow, expensive, and has to happen again every time anything changes. You can't retrain a 100 billion parameter model every time someone edits a company doc. So instead of teaching the model to memorize more, engineers gave it something closer to a librarian, a way to go look something up, on demand, right before it answers. That librarian pattern is called Retrieval-Augmented Generation, RAG, first described in a 2020 research paper out of Facebook AI, combining a model with an external memory it can search at the moment it's asked a question. The core idea is almost anticlimactic. Don't make the model know more. Make it search first, then answer using what it just found. Here's the actual mechanism. Every document you want the AI to draw on, a manual, a codebase, a support archive, gets sliced into small chunks. A paragraph, a function, a support ticket. Each chunk gets converted by an embedding model into a long list of numbers, a vector that represents its meaning geometrically. Every chunk of every document ends up as a point in a vast mathematical space of meaning, stored in something called a vector database. When you ask a question, that question gets converted into a vector too, using the exact same embedding model. Then the system does something conceptually simple. It looks for which chunks sit closest to your question in that meaning space, a similarity search, often using approximate nearest neighbor math to do it fast across millions of chunks. The handful of closest chunks are the system's best guess at the parts of everything we have that are actually relevant to what you just asked. Those retrieved chunks don't get memorized, they get pasted directly into the prompt, right alongside your question, before the model ever generates a word. The model isn't recalling, it's reading, fresh in real time, text that was handed to it seconds ago. That's the whole trick. The knowledge was never in the model, it was handed to the model just in time. This is why a coding agent can answer questions about a codebase it's never trained on. It indexed your repository into chunks and retrieves relevant files as you ask. It's why customer support bots can answer from this week's policy update. It's why enterprise AI assistants can cite your own internal documents instead of the open internet. Almost none of that is the model knowing your company. It's RAG, quietly running underneath. But chunking is where this quietly breaks. Slice a document badly, and a retrieved chunk might say, the company's revenue grew 3% over the previous quarter, with no company name and no quarter attached anywhere in that chunk. The system can retrieve a technically relevant sentence that's functionally useless, because slicing text into pieces throws away the context that made the sentence meaningful in the first place. In September 2024, Anthropic published real numbers on this exact problem. Their fix, called contextual retrieval, has the model write a short explanatory note onto each chunk before it's stored, restoring the context chunking destroys. The measured result, adding that context cut retrieval failures by 35% on its own. Combined with a second search technique, the failure rate dropped by 49%. Layer in a re-ranking step on top of both, and failures dropped 67%. From a 5.7% failure rate down to 1.9%. Real, published, measured, not a marketing claim. Even a well-built RAG system isn't a truth machine. The model can still misread a source it correctly retrieved. One documented failure had an AI retrieve a real historical fact from a chapter title, then misinterpret its meaning entirely and state something false with total confidence. Retrieval finds relevant text. It doesn't guarantee comprehension. Garbage or badly chunked retrieval in, unreliable answer out. The model is only ever as good as what it was just handed. So the next time an AI agent seems to just know something from outside its training, your files, this week's news, a codebase it's never seen, it didn't remember it. Somewhere in the milliseconds before it answered, it searched, found the closest matching pieces of real text, and read them once, right in front of you. Not memory. A library card, used automatically every single time. If you want to know what these agents can actually do, subscribe. There's a new explainer every week.